So let's begin our topic, that is drones and drone security networks, frameworks. So the first thing is, what is drone? So first we have to understand that what is a drone. We all used to say that drones, anti-drones and things. See, drones is not a simple word. It's an abbreviation of a term that is DRONES. You must have learned about the drones from last 4 days as I came to know recently. But I will also try to throw some light on the basics so that I can connect my future slides to the basics. So D stands for dynamically, R stands for remotely, O stands for operating, N stands for navigation, E stands for equipment. So anything which is dynamically and remotely operated and it's a navigation equipment, then it will be qualified under the category of drones. Now, drone terminology has been recently classified into other three areas, that is UAV, UAS, and RPS. So, being engineer, we should know that which component or which equipment is UAV, which equipment is UAS, and which equipment is RPS. For a layman language, everything which is flying, which is unmanned, it should be a drone. But being an engineer, it's our moral responsibility to code and conduct the exact terminology which is supposed to be delivered to the client or to the other customers or to your students. So UAVs are those vehicle or equipment which are termed as unmanned aerial vehicles or an aircraft which is capable of a flight without a human pilot on board. So anything which can be remotely operated and can fly up to a certain endurance. In India, the current endurance rate is 45 minutes to 1 hour. And in case of higher category of drones, it is up to the 5 to 6 hours endurance. The second one is US, Unmanned Aircraft System. Unmanned aircraft systems are those systems which encompasses the aircraft and its associated elements. And the third one is RPAS, that is remotely piloted aircraft systems. Generally, it consists of VTOL category of drones, vertical takeoff and landing drones. So these are the three basic terminology which are used by the drone engineers or the drone security engineers. Now, if we talk about the classification of the drones, then broad classification of the drones will be done on the three parameters. First is through the design of their wings. See, drone is not a specific cup of tea of any specific branch. That is, we cannot say that a drone is a component of electronics and communication engineer or a computer science engineer or a IT engineer or an electrical engineer or a mechanical engineer. It's an amalgam of all the technologies, all the specializations. So whenever you are dealing with the drones, you must understand that it is not a baby of a specific branch. It's a outcome of a engineering only. So on the basis of the wing design, it means that it is coming on to the prerogative of mechanical perspectives. So there may be a fixed wing drones or it may be a rotary wing drones. In a case of fixed wing drones, rotors are mounted on the wings. And in a case of rotary wing drones, the motors or the rotors are mounted on the top notch edge of a arm. In case of a drone, I will also teach you the different terminologies of the components of the drones in the subsequent slides. Then the second classification will be on the basis of the size. It may be a micro drones, small commercial drones, large industrial drones. If we go on a deep dive mode, then the drone which is having a weight less than 250 grams, it comes under the category of nano drones, for which there is no need of any license to fly in an open area, but you cannot fly it in a red zone. Rest of the zone, our space has been classified into three zones: red zone, yellow zone, and green zone. The nano drones can be flown by anyone, me, you, or anyone can fly the nano category of zones. But if the drone's weight is in between 250 gram to 2 kg, then it comes into the category of micro drones. Now the authentication from the government licensing authorities, that is DGCA, comes into play. So it means if you want to if you want to fly a micro drone, you need a license. Then from 2 kg to 15 kg, it's a medium category of drones. Under this category, all the agriculture drones, surveillance drones, tactical drones, thermal drones, all category of drones comes under the this bracket of medium category of drones. Generally, it is used by the defense purposes, for the defense purposes as well as for the surveillance purposes. And beyond the category of 15 kg weight, It comes. Hello. Ma'am, can you mute the? So the other category of drones are the large category of drones, which are tactical drones. Like in currently in Opshindur, we have seen that we have destroyed the Karachi air base. So the drone which is used to destroy the Karachi air base is Bakhtiyar drone, which have been bought from the Russia. So these categories are defined by the size of the drones. And the third is that how the drone is getting its own power. It is electric power, that is battery based. Generally, batteries in drones are LiPo batteries. LiPo stands for lithium polymer. But nowadays, there are a lot of other categories of batteries which are employed in the drones, like lithium ion, solid state, sodium ion, and different categories of drones. See, whenever we are selecting a battery for a drones, we should understand that what are the requirements in the case of drone. In a case of drones, we require a high thrust power of batteries. Initially जिसके पास thrust ज़्यादा हो, that battery is required. The rest we are also running the drones on fuel powered methodology. Generally, two-stroke engines are employed in it. So these are the broad areas on the basis of which we used to classify the drones. Now the core drone components are six in nature or six in numbers. First is frame, the structural backbone that houses all the components. Material of the drone may be material, it may be carbon fiber, it may be plastic. Plastic के case में it will be PP plus T20, polypropylene plus T20. It may be a metallic, it may be a thermocol forming, or it may be a wooden drones. In in other categories of for special purposes drones, we used to design a aluminum composite based drones, but these are in the
अले
category of
वॉक
kamikaze.
करने नहीं जाऊंगा आज।
The second is motor and propellers. The motors are brushless DC motor. Why brushless DC motor? Because we tend to provide the noiseless motion in the case of motor, because if there is a noise in the motion, then the acoustic signature can be generated through the different uh, we can say the different side, and it will also create a noise and vibration harness in the system also. The another one is flight controller. It is considered as a brain of a computer. It used to integrate all the signals which are coming of a radio control system. It is coming from the satellite communication, or it is coming from remote pilot area, or it is coming from the different LTE based signals, or it may be from radio frequency. So each and everything is controlled by the flight controller in case of drones. The other one is battery. That is, I have already told you that it's a lithium polymer batteries which provide power. Power management system is also equipment which has been installed in the each and every category of those. That is known as PDU. Then electronic speed controllers, which regulates the motor speed on the basis of the signals which has been deliberately delivered by the flight controller, and on the basis of the algorithm which are already fitted in terms of machine learning into the drones. So whatever the signal a pilot is giving to the drones, that signals are further processed by the flight controller, and then the equivalent subsequent amount of signals has been transferred to the electronic speed controller to control the flight dynamics. And the other system integration components like different categories of sensors, different categories of EOs. EOs means electronic optical instruments, or different categories of we can say that payloads, that different category of payload assemblies, that what actually we are going to use our drone for which purposes. So whatever the assembly we have installed, it may be agriculture, it may be firefighting, it may be kamikaze, it may be bomb dropping, it may be missile launcher, or whatsoever it is. So there are n number of application which you guys are seeing right now in the market or in the area or in the news. So each and everything is actuated automatically in a nature. So all these automations comes into the category of system integration, and there must also be a connectivity in between the flight controller as well as the system integrated equipment so that a person who is flying this particular drone from a remote position can operate in it in a operational mode as well as in a autonomous mode. It may be a possibility that there is no pilot required, then this category will come under the category of autonomous drone. In that case, we have to give the waypoints to the drone, that what operation does this drone has to perform. So this is a fully autonomous mode. Generally, there are three categories or three mode of transfers in a case of drone. First is GPS, second is manual, and third is loitering mode, or we can say that in a GPS denied mode. So that is the perfect choice of a pilot, that in which mode he or she wants to fly the drone. So now again, as the current topic is drone security, so there are three buzzwords in drone security. So first, we have to understand that what is the drone security's problematic areas, or what security we should provide, to which type of threat. So generally, there are three type of threats in a case of drone security. First is spoofing, second is jamming, and third is detection and testing. In the case of unmanned aerial vehicle or a UAV, it becomes increasingly integrated into a critical infrastructure, defense operations, and commercial application. Understanding and mitigating the security threats that has been more essential. This presentation explores the evolving landscape of a drone security challenges and the sophisticated methodologies used to protect these systems from the malicious actors. This is a crisp of this particular, in my views, this topic is quite relevant and has a very inheritance to the topic of this particular FDP, that what are the key areas, because this area is not till now cherished by any of the research institute, any of the IITs, or anywhere in the world. You will not find any drone security testing lab in India where you can see or where you can check that whatever you are making or whatever you are assembling or whatever you are integrating, is it perfectly threat proof, or the data which you have inculcated in your drone or in your flight controller is completely safe. Else, whatever the drone you have captured from the other side, is it safe, or it's just a, we can say that a hobbyist drone or whatsoever. So this testing is not available right now due to some or other reasons. So we have to understand that what are the possible threats which are associated with the drones. So first we will understand that what is drone spoofing. See, drone works on the GPS coordinates. It is not necessary that it should always work on a GPS coordinates, but generally all the categories of drones works on the GPS coordinates. I'll not say that if you're not having a GPS in your drone, then your drone will not fly. It will fly, but in that case, you have to integrate multiple sensors. For example, for getting the altitude distance, you have to employ a lidar sensor. For getting the pressure and other things, you have to get the barometers. For getting the dynamic balance, you have to go for the gyroscope sensor. But all these things are also coordinated through a manual mode. But in the case of GPS mode, you can fly it in a autonomous mode also. So GPS spoofing represents one of the most sophisticated threats to the drone navigation system. It is related to the navigation system of a drones. Attackers, or the, we can say that enemy, it used to transmit the counterfeit GPS signals, and that signals are stronger than the legitimate satellite transmissions which we are already connected through our drones. That effectively hijacks the drone positioning system, and that deception causes the drone's onboard computer to calculate the incorrect coordinates. So if the spoofing is done, then automatically whatever the coordinates you have decided for your drones to land or to take off, that will be wiped. In other words, we can say that there is a spectrum of fake signals on which the different coordinates are patternized. And in a case of drones, once the attacker used to do the spoofing, he used to create a mimicking of the different false signals. And on the basis of these false signals, false coordinates were calculated, and drones used to land somewhere else wherever it is supposed to land on some other space. So modern spoofing attacks have been increasingly sophisticated, utilizing the software-defined radios, that is SDR, and GPS signal generators that can be purchased commercially. This accessibility makes the threat particularly concerning for both military and the civilian drone operations. So nowadays, whatever we are seeing the benefits of the drone, it is also a threat for us that it may cause a lot of harms. In a recent activity in India and Pak war, that is of Sindoor, we have seen that none of the soldiers from Indian side or from Pak side has come onto the front. This is a war of completely a war of drones. On the other side, we can also see the Russia and Ukraine war. There are only drone wars, spider formation, kamikaze formation, swarm formation, whatever the different techniques they are using. So they are using the drones as a form of a soldiers. So this day is not so far away in Indian categories also that Indian Army or Indian Air Force or Indian Navy will use the different technologies for their war purposes. So warhead will be transported through drones. Fight should be done through drones because right now in India also we have developed such category of drones which can hit the target on a point blank without a deviation of not more than 10 centimeter, and it's a matter of pride for all of us. Second is drone jamming. Drone jamming attacks the flood control frequencies with a high power noise signals, overwhelming legitimate communication between the drones and its operator. This creates an impenetrable wall of interference that prevents command signals from reaching the aircraft. It may be understood that there is a connection in between the RCS, that is remote, and the drone and the satellite. So in a case of jamming, what we used to do, okay, see, you have to understand that on which frequencies these drones works. So in India, there are two frequencies on which drones are working. Why only two frequencies? Because these two frequencies are free. First is 2.4 gigahertz for the data transfer, and the second is 5.8 gigahertz for the video transfer. So any of the frequencies once override by any of the device, it may be RF detector or it may be a jammer or it may be a we can say that amplifiers. So if we used to throw high frequency or high range, high gain power signals to that particular range and it intercept the communication linkage in between the drone as well as to the remote, then automatically this jamming will be done. And this is what is the current technologies which is working out now, working right now. But I'll not say that this jamming technology is the only way. There are currently three ways which are running now in Indian context. First is this RF detector jamming, in which we used to detect the RF signals which is coming onto the frequency of 2.4 or 5.8. Once they are identified, we used to throw the higher frequency signals in the same direction so that the signal range of this drone can be hijacked. Second is LTE based passive radars, in which once the drone is flying, let us suppose we can take an example of your institute only. Let us suppose there is a drone which is susceptible and it is flying onto the college, your institute's airspace. See, and anyhow you are not having any radar or any RF detector, then the passive radar comes into the play because it is not it has a maximum chances that your institute may have a tower or there may be a tower which is nearby to your institute. So the passive radar works in such a way that whatever the signals have been transmitting from this cell tower, they may be striking to the drones, and LTE passive radars will receive these signals and calculate the total distance that where the drone has been detected, and short kill technique or a soft kill technique can be used for neutralizing that particular drone. And the third method for the higher category of drones are radar, because these two techniques have a limitation. In a case of RA detector, we can go for maximum range of 7 kilometers. In a case of LTE passive radar, we can go for a maximum range of 5 kilometers in a horizontal distance, as well as 200 meters to 5 kilometers in a altitude range. So these are the basics which you must encounter once you will enter into this particular field. So anybody who is planning to do research or want to do something very charismatic in this area, they can go for the LTE based passive radar generation system for a drones. Drone detection technology, as I have already tell you, that detection of an unwanted drone or unidentified drone can be first what we people are doing or the defense people are doing. First, very first is through the naked eyes. but it also has a limitation of 1.5 to 2 kilometers. Second is radar detection. Third is RF signal analysis, radio frequency wave signal analysis. Third is acoustic signature. Each and every drone have a special or unique signature pattern of their noise. It may be through their cross-sectional dynamics, or it may be through their RCS. RCS means radar cross-sectional area. Generally, drones which are available in India having a range of RCS of 0.01 to 0.07. So there may be a defined acoustic nature of a particular drone which can be feed earlier to your software, and that software will identify that which category of drones is coming towards you or going through by your area or your airspace through the identification with the similarity of the data which has been already fed to your software. Second is optical and thermal cameras. Of course, optical and thermal cameras are also a important concept in case of a night vision. And the last one is multi-sensor fusion. There are a lot of other sensor facilities which are available, which can identify and detect that there is some unwanted flying object which is coming onto the way. But there is also a challenge which is coming nowadays, that each and every drone used to detect or used to create a path which is also having a resemblance with the birds. So whatever the system you are installing onto your premises or to onto your critical infrastructure, it will resemble to the same system which has been created through the birds. So there is a problem of false signals which we are facing or which we all are facing. So we as engineer have to identify that which signal is required to detect the drones, or out of 100 signals, which is the signal which is dignifying the presence of drones. So false signal false signal processing is also a cream area to work upon. So the core aspects of a drone security we talk about, that are, we can say that we have to establish communication link protection, because right now whatever the modern protocols which are used in, we can say that in a drone technology, is Maveling 2.0 implementation, AES encryption, and message authentication. So whatever the FPG or FHSS techniques which are used nowadays, that should be also secured. It may be through IoT security, or it may be through a sequential locking, or it may be through a counterfeit technologies. But we have to see it that the communication link protection should be done. Once it is hijacked, then you cannot control your drone, you cannot control your remotes. Whatever the command you are sending through your remote will not serve the purpose, and your drone will be the slave of some other client. Second is authentication and access control. It should make sure that whosoever is having the authentication of a drone, he or she can only fly it. So in my suggestions, it may be on the basis of QKD. QKD means QKG, sorry, it means quantum key generations. So likewise, whenever you are transacting any money from one account to another account, there is a need of OTP. In a similar manner, there must be a process of a quantum key generation technique, so that once you are operating a drone, so you are the liable or you are the authenticated person, and you will receive a key. Only after entering that particular key, you can fly the drones. So this is also a secure technique by which you can authenticate and control the access of a drone. And the third is data storage encryption. Again, I will say that quantum will serve the purpose. Whatever the data has been stored in terms of your cross links, in terms of your codes, in terms of your Mavlink protocols, in terms of your data security, in terms of your communication security, in terms of your FNSS signal generator, FNSS data, GPS data, gloss data, GNSS data, whatever the data you have fed or recorded by the drone, it must also be secured. So the encryption of that data, which is in your drones or in the drone of an enemy, that must be encrypted, and you have the capability to decrypt the drone which is already encrypted through the other side. So there is, that's why I have said that in India, in engineering field, it is a dying need of having a drone security testing lab. Nowadays you are seeing that a lot of institute, a lot of agencies, a lot of factories, a lot of companies are coming out, and they are saying that we will teach you how to fly a drone. See, flying drone is not going to serve a purpose. You can understand it in a day of 2 or 3 days, hardly. But being engineer, you should understand that what are the possible threats associated with the drone technology, and you must be able to secure it. Likewise, then only you can do the monopoly in this technology. Otherwise, assembling, getting the drones from some wanted or unwanted companies or countries and assembling it onto your lab, it's not going to do a serve. It's not going to serve the purpose. And automatically, in terms of business, we can say that if you are just assembling, you're not integrating anything, you are not developing something, you are not developing the design, you are not developing the processes inside the drone, then of course you are not going to make the money also. So this is the point which is must be considered. So now, what are the testing methods which one should apply while detecting or testing a drones? Or before the induction of drone in your critical infrastructure or in any of the critical infrastructure, such test must be inculcated. And for doing such tests, there is a need of infrastructure, and that infrastructure should contain a hardware security testing so that the physical inspection of the circuit boards which has been installed inside the drones, JTAG, debugging interfaces, component analysis, and lot of other things like firmware extension vulnerabilities, side channel vulnerabilities, hardware tampering detection mechanism, supply chain of the hardware can be identified. Second is software vulnerability scanning. There may be a chance that there must be a malicious code in your software which has been installed in the drones. It and the software are used in three categories, in three spaces in the case of drones. First, to establish the connection and communication in between the remote pilot and the drone. Second is in between the drones, and third is drone to satcom, satellite communication. So there must be a security threat. There is a security threat in this communication channel. Third is communication protocol. Whatever the communication protocol you are following, it may be through GPS or RF or telemetry or Wi-Fi based, or we can say that remote based. It should also be that protocol should also be tested. And for testing, using control signals using the SDRs and different, we can say that parametrical devices through radars, that should also be taken into the consideration. And the fourth, and the last one is penetration. The fourth one is penetration testing, simulating the real world attacks, including GPS spoofing, RF jamming, command injection, autonomous system manipulation. So these are the four tests which we should take into the consideration. I'll request all the budding engineers to take a note of these four tests. And I would love to hear from your side that what solution you guys can provide being an engineer to the society. And definitely we will support your institute, your batchmates, or in like anything, if you have certain solution in these areas. But that should be completely made in India, not from some other countries. Arun sir, is there anyone from REC Kannauj? Arun sir,
I am already connected. Huh.
Arun sir, do we have our students also in this presentation right now?
No, only two or three volunteers are there.
Okay, so in case
Students are not connected
if we
because it
have the
is a faculty development program.
okay, so
So,
if we have professors from your institute also, then I'll also suggest that they can also proposal.
अरे
So
म्यूट
there
से
are a lot of
लिंक चाहिए कहाँ गया
So there are a lot of fundings which are available from different defense sectors, from DRDO, DLRL, DGQA, which is providing a lot of amount of fund. Lot of means a heavy amount of fund on these areas. So I'll request all the colleagues, professors from the Institute of Arun sir, that you can take a note of it, and you can suggest your institute. We will also support you in getting this funding, because this is the buzzing area. That's why I have called Arun sir and disturbed him also,
no
because
no
this
no
is
no
a buzzing
this
area.
is not disturbed, this is just information. Thanks for that.
So this is
I think some MTech and PhD students are there. They are allowed to attend the program. but mostly the faculty members are attending the program,
No issues, sir. No issues. If
and
their
three or
professors
four
are there, then also it will
students.
serve the purpose.
Okay,
See,
I
the
think they are
thing is कि ये information basically हमारे मतलब academia में पहुंच जाए, so that support can be also provided from your side.
okay.
So tools used in drone security testing are SDRs. Currently, what we are using is HackRF1, BladeRF, USRP, and there are other tools also which are used as and when required. Network analysis tools, they are also basically customized as well as already established. Reconnaissance tools like Nmap, Aircrack NG, port scanners, and other category of tools. And the open source platform like Ardu Pilot, PX4, Maveling 2.0, Mission Planner, or we can say the JIY and Agri Assist, and there are a lot of other platforms, open source also as well as the customized also. Customized की अगर हम बात करते हैं तो we can have platforms from Thalys, we can have platforms from Hot Dog, we can have the platforms from Intel, we can have the platform from Infosys, and a lot of other companies are also in a line to provide this basically platforms for customizing the category of drones. So if we want to have a drone security, drone testing lab or drone security testing lab, then these are certain things which are very, very much required to identify or to test any category of drones for authenticating it. That budget conscious researcher can establish a effective testing environment. I'm not asking that you should receive any fund or somewhere else. If you want to do work, then you must have these basic things that consumer drones like Cheerson CXW, it means that agriculture drones also it will do the serve the purpose. SAM XXC and X5C1, that is 2.4 gigahertz control, excellent for the RF testing. Uh, Unfortunately, you will get the drone which is working on 2.5 gigahertz. If you have the capability, you can fluctuate the frequency from 2.1 to 2.9. And in the case of video transfer, you can also fluctuate the frequency from 5.1 to 5.8 only. Because going beyond the 5.8, you have to take the permission from defense. They are not available for us. But anyhow, if you get the modem, you can communicate it also. But I will not suggest it because it's a criminal offense. So the initial hardware which is required for testing these things again are Wi-Fi adapters supporting monitor mode and packet injections. For example, alpha code also I have given. SDR for spectrum analysis, HackRF1 or we can say Keysight or Sanitel. There are a lot of other companies which are providing the same. GPS spoofing equipment, high performance computer for the signal processing and the data analysis, as well as the spectrum analysis for identifying the jamming attempts. Software, it's not necessary that you will go with the Arsenal. You can go any of the software which can provide you the capability of the reverse engineering mobile control application. Case study, we take about an example of detecting and mitigating the spoofing. So first is the detection phase. We can say we can take a live example. See, whenever a detection of any drone is done, it is done in a sequential manner. So what we used to have installation of a system inside the critical infrastructure premises, which consists of a RF detector, which consists of a jammer, consists of an antenna, as well as a power source. So the thing is, whenever any drone is coming, our detector used to identify it. Now you have identified that there is a malicious drone which is coming or any flying object which is coming. Second thing is to know the direction of that particular drone, through which direction it is coming. So in that case, we used to install a LPDA category of antenna so that we can get the direction. Third, you have analyzed, you have detected, now you have to mitigate it. So what we used to do, once we identify the nature of frequency, nature of signal or the acoustic signature, whatever the method we have involved, now we got the chance to throw a higher frequency of signals to that particular direction in a angular mode. Angular mode means the beam angle must be greater than 30 degree. Otherwise, your gain will be reduced. So in this way, we used to mitigate it And once these interruptions in between the communication channels of the drone as well as of the RCS, it may be in an autonomous mode also, then also it will get jammed. So this is what is a complete phase, how a drone detection, mitigation of the spoofing and jamming, or forcing the drone to return back to a home position is done. Generally nowadays, currently the work is also going to be done on a LTE based passive radar because it's a very heavy equipment, heavy in the terms of financially. So generally, research is also going on to the LTE based passive radar spoofing, so that the signals which are coming from the tower to tower connectivity, they once they are interrupted by any of the drones, then these signals, reflected signals, were absorbed by the LTE passive radar and will help in the detection of the drone's exact position or the coordinates on a Alaska scale. So this is one of the example we can say that how this process can be done and can be improved. Securing the skies requires vigilance and innovations. Currently, Indian government as well as the different governments are also paying a lot of analysis, a lot of money on this particular area because aerospace management is a very critical, we can say that, issue nowadays, which each and every is associated. As the unmanned aerial vehicles are proliferating across the military operations, critical infrastructure, monitoring, emergency responses, commercial delivery systems, security imperative grows exponentially. The conversion of these accessible attack tools, sophisticated threat actors, and high value targets creates an environment where robust security is not an optional, it is an essential tool. So, in my opinion, also, as well as in the opinion of the current scenario of the drone industry, as well as in the defense. So, guys who are coming, irrespective of their branch, who are coming with the knowledge of AI, ML, FPGA programming, as well as in terms of these zone security testing, will going to lead the show. So this is what is we can say that an outcome of this knowledge. Now framework, there are a lot of frameworks which are available nowadays and that can be customized also. So drones and drone security frameworks currently what we are using are we are working on the system architecture, that what the architecture has been installed inside the drone. It has three essential components. First, the drone itself. It may be a helicopter, it may be a hexacopter, it may be quadcopter or octocopter. It may be a VTOL category, it may be a fixed wing. Whatever the architecture it has carrying with. Second is ground control station, and the third is the robust communication links. Generally, it is 2.4 and 5.8, but I will not say that only 5.8 gigahertz drones are available now. We are also having a drones which can mitigate its own frequency channels in the flight also. So we are saying that your system is showing that the communication has been established in 2.4 gigahertz, but in actual it is working on 2.4139. So that 0.0139 will also do the difference, and your all the systems of getting it mitigated or identified will not work. So that we have to understand. The core components are flight controller, which is, we can say that, a brain propulsion system, that is motor and propellers. Sensors, there are a lot of sensors which are installed, and these sensor installation is purely on the basis of the purpose for which we have installed our drone, and the communication module, wireless links, or the telemetry data, whatever it has been installed. That purely depends upon to the system engineer who has designed this particular drone. Anatomy, again, these same things: communication antenna, propulsion system, flight controller, GPS module, battery pack, camera, and sensors. The growing role of drones and emerging security risk nowadays are not only a cyber threat, but the GNSS vulnerabilities also. There is a heavy reliance on a GPS for a navigation, creates critical exposure to spoofing attacks, signal jamming, sophisticated cyber attacks that can mislead or disable the drone mid-flight. Second thing, there is also a real world impact that GNSS spoofing can redirect the drone, of course. And the live example of this spoofing is the Indira Gandhi International Airport, Delhi. So that is also an example that how this technology, if it is not controlled, then how bad effect it can give to the society. And there are a lot of cyber threats landscapes again. That is signal spoofing, data tampering, denial of service attacks, communication interception, and the uncontrolled or unauthorized hijacking. So that we have to take into the consideration. Cybersecurity challenges in drone operations are vulnerable communication. So once your communication is intercepted or hijacked, then anything can be transmitted through your systems. It's just like you are having another person's ATM with PIN. Second is expanded attack surfaces. Complex cyber physical interfaces creates vulnerabilities beyond the traditional IT systems. Standardization gap, because nowadays each and every component of drones can be easily bought from the open market, and mission critical risk. Once the successful attacks can compromise the payload integrity, that I will not we can say that elaborate on a public platform. If you want to have some details, you can directly connect through Arun sir to me, that what is the mission critical risk, what are the different risks which are associated with this. So now a risk-driven security framework for drone, if we talk about, then again we will come on to the back slides. That is access of the use, access of the control, system integrity, data confidentiality. Because nowadays drones which are operating in the different critical infrastructures, having the storage capacity of the data of more than 10 terabytes. So you can understand that how much confidential, how much secured data it may be once it is transmitted to a aerospace device or from a airspace. Then the event response and identification and authentication. So these things are also taken into the consideration, that how it should be secured, how the your framework should be tightened enough to counter attack all these threats, and there should no risk before inducting or before employing any drone to any of the critical infrastructure, because it's a moral responsibility of each and every scientist or engineer or a fraternity to control all the things which are critically required, which are critically important for the nation's security. Then we talk about the multi-layered defense for drone operations. So in a case of defense specifically, we will say that first the user authentication is required for operating any category of drone. Then once you are identified as an authorized user, then the command signals and control security will be provided through the specified unit. Then the data encryption is also through the military grade encryption protection, protecting mission data, telemetry and payload information. Each and everything is first recorded, decoded, and encrypted in the drones. Once it is landed to X site, then it is again decoded and decrypted. And the system recovery, there is a resilient recovery mechanism ensuring the mission continuity after the security events. So don't worry if the drone of any of our defense agency is found, it's not going to produce you any harm. But it is not supposed to be taken into a lighter matter. It's our responsibility to make it more harder, more stealth. So advanced security measures right now in practice are AI-powered threat detections, machine learning frameworks like Drone Sentinel analyze the flight patterns so that you can easily identify the sophisticated attacks in a real time. Second is orchestrated incident response, automated system rapidly isolating the compromised zones, and also without any human interventions, all these attacks can be nullified. Third is secured protocol implementation, that is, next generation communication protocol replace the vulnerable legacy systems. And the third is UTM integration, unmanned traffic management system, coordinate safe airspace so that the data or the information of your geo coordinates cannot be compromised with anyone. So these are the current practices, but these are not but these practices are not limited. You can enhance it also. Case study for securing drone in GNSS defined environment that we have already discussed. So I'm skipping this particular slide. Securing the future of drones, operations, transformations. Drones are fundamentally transforming the industries from revolutionizing the last mile delivery to enabling precision agriculture. See, it's an example of a case study that if you want to spray a seed or insecticide on a 1 acre of land, then you have to employ two people for 2 days. And on the basis of the general capital data of India specifically, So we have to hire a person for a day, then it may cost us for 500 rupees. So for two-person for 2 day, it will cost us 200 if we talk about economically. Second, water resource. For a spray of 1 acre of land, we will require 125 liters of water. Third is again on economical background that it will also require a human exposure to the pesticides. But on the other side, if we talk about the agriculture or smart or precision farming, if we employ a drone, then it on the cost of that 2000 rupees, it will charge only 1 unit of electricity, which in terms of Delhi, it will be 7 rupees or 10 rupees. And in terms of UP, it may be 12 to 15 rupees. On the other side, if we talk about the time, for 1 acre of land, the human labor will take 2 days. On the other side, drone will take only 7 minutes. On the third side, human labor will take 125 liters of water. The drone will take only 10 liters of water. So we can see the comparison that how the payback or the ROI can be generated through the this particular area. So any entrepreneur who is thinking about these technologies in agriculture terms, this can also be a key area, or we can say that a gray area to work out. But the call of action in this technology is to invest in the drone cybersecurity research and development. You have to adopt robust tested security frameworks, prepare frameworks, customize frameworks as and when the technology is getting grained out or getting polished. So we have to see that how these technologies will do the purposes. Drone detection and information security that we have already discussed. The rising threats of the drones, they have no limits. But of course, whatever the technology upgradation in a drone is going to be done, these are also going to be under the control of the we can say that in terms of India, it will be under the DGCA. In terms of US, then it will be in the US federal agencies. Recently, in 2021, Indian government has also framed the different drone rules and bylaws. And in this year or by the beginning of the next year, we are also going to have a drone laws. So from my side onto the topic which we have decided is this: if anybody wants to ask anything irrespective of this topic, now this forum is open, and I'll also request Arun sir to please connect the faculty members if they want to have certain topic need to be discussed. Else, if they want any other physical example of these technologies as well as the security agencies, then also we can discuss. But theoretically, or we can say that in terms of technology, this is the basic. Hello everyone. Now this portal is open for any questions you have. Sir, any suggestion from your side?
I am waiting for the response from the participants. I think we should wait for 5 minutes. If there is any questions,
Sure, sure,
then
sure,
we will first discuss that.
sure, sir.
Good evening, sir.
Good evening.
Sir, actually, in India, where the speed connections, internet connectivity is a big issue, their
Uh-huh.
deployment of the drone for the feasible solution that is possible, or still it is a hypothetically the discussion is going on and we are only theoretical approaches we are following, but in the practical scenario for the civil application and other applications, still the I think that Wi-Fi connections and other issues are a major that problems. So how come that problems we can resolve?
Vivek sir, practically you are absolutely correct. But right now the technology is has been developed that the flying capabilities of a drone has been rerouted to the SDRs. Plus, automatic waypoints have also been developed so that the dependency on the internet connectivity is reduced. But yes, practically, if you are not having a good amount of internet connectivity, then it will create a threat.
That is the reason, sir. Because the application, when we are writing any project proposal or anything, so
Uh-huh.
there we are writing for the rural connectivity or emergency situation and other things. But the
Uh-huh.
main challenges is the internet connectivity. That is that I can observe this nowadays is the main problem. So, other than that wireless connection or Wi-Fi connection, any other communication media we can use in the optical communication or
Yes,
drone-to-drone
yes, yes.
communication?
Yeah, currently optical fiber communication is also in trending, but optical fiber communication also have certain disadvantages because it is bounded to a ground stations. So whenever the drone is flying to certain particular area, it also have a tendency to get stuck through trees or some other critical infrastructures like heavy tensile lines and others. So this is a problem which is associated with the OFC category of drones. Third, we are also developing a laser-based drones, but again, it is also having a certain problems that laser amplifications cannot be possible more than 10 kilometers. So this is also a problem. But yes, a lot of technological advances are going to be done in a recent coming time in terms of optical fiber as well as in laser.
Okay, sir. Thank you.
Sir, I have a question, sir.
Yes, Rajesh sir, your communication is not clear. Please come again.
Yes, sir. My question is,
Manish sir, he has posted the question: how does geofencing technology
Uh,
help prevent drones from entering restricted or sensitive zones?
So geofencing technologies is applied on the our matlab the drone. We can say that if we are having the drone, then only we can go for the geofencing technology. We cannot control the geofencing in terms of the enemy drones. So if we are the owner of a drone, then we can go for the geofencing. The other party cannot tolerate this geofencing technology because they are not bound to it. They must have a different security channel. They must have a different transmission signal connectivity. So geofencing is bound to our drones only. If we want to have a geofencing, for example, for a village or from a taluka or from a district, then we can provide it to our drones, not from other drones.
Good evening, sir.
Good evening.
Sir, my name is Abhijit.
Okay.
I'm doing a research on unmanned aerial vehicles.
Okay.
Sir, I would like to know about the target identification algorithms. Like you have given an example about the defense drones, right?
Uh-huh.
Is able to identify targets up to 1 centimeter resolution, 10 centimeter resolution. I'm sorry.
Uh-huh.
So, what are the basic algorithms that could be used for this target identification? Do you have? Can you just give an outline or something related to that?
Yeah,
More
it's on the
insights
basis of
related to
a
that?
spider formation as well as on the ant therapy. But beyond this, I am bound to not to disclose. But yes, I will tell you that it is working on ant therapy, elephant mechanism, as well as on a spider mechanism. You can go through the literature, you will get the answer from these buzzwords.
Okay, sir. Thank you, sir. Thank you.
ఇచ్చేసిందంట ఆ పిల్ల దగ్గర ఉన్నాడు నువ్వు పని కూడా అనవసరం ఎందుకు తీసుకోవడం మంచిది వాళ్ళు
Hello. Hello.
పడితే కళ్యాణం మళ్ళీ
Hello.
जी राजेश सर बताइए.
Sir, yes, sir. Sir, I have another question. Sir, what steps can operators take to basically to protect their drones from hacking or jamming?
See, there is no such step which can be taken from the, we can say that, operator. But yes, for basic, we can say that it's before starting or before taking off a drone, he or she must see that what are the number of satellites which are showing onto the RCS. It must always be greater than 12, so that the spoofing cannot be possible on a signal strength of more than 12 satellites. Second, whenever he or she is feeling that the controls are not operated by a drone, immediately she or he should activate the RTL command. RTL command means return to home command, so that a major destruction cannot be done by the X person. So these are the two methods by which he or she can operate it smartly. But rest of the other spoofing and jamming will be on the control of communication protocols only. He is just only operating the device. He is not having any decision taking capabilities except the flight dynamics.
Thanks, sir. Thanks a lot.
There are two more questions. One is from Janila. How we can establish rural communication using drone?
How we can establish, sir?
Rural communication using drones. Can you give a brief outline about the technology?
Rural, I am not getting the exact word. Rural.
Rural.
Okay, rural communication. There, yes. See, in a flight controller, the protocol which has been used in basically in all the categories of flight controllers, it may be DJI or it may be NASA or it may be Cube Orange, whatsoever it is always using the Mavlink protocol. So whatever the communication protocol you want to establish, you have to just override onto this particular, we can say that a channel tree, and whatever the communication mode you want to apply, that also can be interrelated onto the Mavlink protocols directly. Plus, the switching of the frequency can also be done through the help of a twin mode modem installation. First is on drone, and second one is on your RCS. So, if you want to have a separate communication channel, then it can also be operated, but limited to only 2.4 to 5.8 bands.
There is one question from Dr. Abhishek. He is asking what methods can be adopted to operate a drone without GPS for indoor applications.
GPS is used for the controlling the coordinates and for acquiring the data of the exact positioning of a drone. So if you don't want to operate the drone from a GPS, then you can go for the lidar and the VR based flying controls. So you will have an installation of a high category of, or we can say that a high graded camera onto a drone. Plus, for getting the altitude descriptions, you will have a lidar sensor plus a barometer, so that whenever you are flying the drone, the vertical distance will be calculated by the lidar, as well as the frontal distance or the frontal situations can be viewed in the VR sensor, or we can say that VR goggle through a camera. It's just an example of a, sir, FPV, first person category of drones. And it will work on manual mode only. So whosoever is designing this category of drones,
Wrong sec-
they must be capable of flying the drone manually mode, because once it is shooted or take off, then you have to control it. No other device will going to control it. They will only show you the real time data. They will not control the drone.
I think we have covered almost all the questions from the participants, and there is no further questions. Then we can close this session. Medha, are you there? Huh?
Thank you. Thanks. It's an honor for me also to speak in front of Arun sir, who is just like our teachers, who have made us to understand the things in like a way so that we can deliver to the fraternity of professors. Thank you, sir. Thank you for everything. And thank you for
Thank you,
providing me
Dr.
the
Manish.
opportunity to speak on.
It's our privilege also that you are sharing your thoughts and your work to the audience. So
Thank you, sir.
we will start the next session after 10 minutes break at 7:25. So all the participants can rejoin at 7:25.
Okay, sir. Thank you, sir.
Thank you, sir. So I can also leave now.
Thank you, Manish. Thank you.
Thank you, sir. Thank you.
Recording stopped. और भी जल्दी मुझे लगता है 12:30 7 घंटे हो गए। अच्छा अच्छा चलो सिलेबस हो गया। रात को मत जागना, रात को मत जागना। ऊपर हाफ स्लीव वाली पहन लिया करो, हाफ स्लीव वाली एक पहन लो, फिर ज्यादा मोटा मोटा।
वही खातिर करके एक्सपीरियंस Madam, please unmute all the participants.
Good evening, everyone.
Recording in progress.
So, good evening, everyone. I am Vikas Dwivedi, and I am co-founder of Bhumi High-Tech and Simnovus, and VP of Bhumi and Tech Equipments Private Limited. Actually, we are into electronic warfare and cyber warfare. So, please interrupt me while going through the presentation. If you are having any question, please do raise your hands. So, most of you are aware about what is quantum computing and what are the quantum computers. So, have you heard any news about the National Quantum Mission? Anybody? So, anybody is aware about the National Quantum Mission? Okay, no problem. So, government has allocated near about 6,000 crores rupees in National Quantum Mission, where they are having certain problem statements and they have to spend up to 2029. So, after this class, please go through the National Quantum Mission, where government want to spend and how they are spending and what are the challenges right now we are in quantum computing domain. So, So these two are the quantum computers. Left one is from IBM and right one is from Google. So do you know what is the common thing between these two computers and companies? Actually, for both the companies, CEOs are Indian. So just wanted to understand what can quantum computers do better? Quantum computers are expected to outperform classical computer in cryptography, breaking RSA encryption. Quantum safe encryption is being developed to counter these threats. Like there are 5 types of algorithm listed in NIST framework. Please go through the same. Then optimization problems, logistic, traffic, defense mission planning, portfolio optimization in finance, network optimization, etc. Drug and discovery, like simulating molecule at the quantum level, designing new drugs, material, and batteries. Then artificial intelligence, faster mechanical learning, quantum neural network, quantum enhanced data processing. And last one is quantum sensing and quantum radar. Basically, these do not require quantum computer, but quantum principle overlap. Quantum computers help simulating quantum sensor and quantum material. Now, what is the difference between classical computer and quantum computer? Anybody? Can anybody tell what is the difference between quantum computer and classical computer? Just wanted to understand, means people are here or not?
Sir, it can take states between 0 and 1.
Yeah, that's true. So a quantum computer is a new type of computer that uses the principle of quantum mechanics to process information. It is fundamentally different from the classical computer like laptop servers that uses bits. In classical computer, basically, there are two types of states, either 0 or 1. And all operations are based on these definite states. Whereas in quantum computing, there are n number of states, right? And quantum computers uses qubit, basically. It can be 0, it can be 1, or it can be both at the same time. So I will show you how it can be both at the same time. So for example, if we are taking any observation at particular time, I'm just stopping this one. Like at the top, we consider 0 and at bottom, we considered 1. If we are taking the reading here, it is more towards 0 and less towards 1. Same way, if again we are taking the reading, it is more towards 0 and less towards 1. Same. So likewise, it can have multiple states, right? As compared to the classical computers. So in quantum computers, the smallest particle is known as qubit. This refers to a combination of all possible configuration. Like groups of qubit in superposition can create complex multidimensional computational spaces. Complex problem can be represented in new ways in this space. So how is qubit built? Basically, different technologies creates qubits. One is superconducting qubit, like IBM, Google are using this one, where electric circuits cool to near absolute zero. And what is absolute zero? It is minus 273 degrees Celsius, which is the south pole. Means this temperatures belongs to south poles of the moon. Then trapped ion atom held in place using laser. Third one is photonic qubit using particle of light, and fourth one is spin qubits or quantum dots, right? Uses electron spin inside very small semiconductor structure. Now here we are representing that how many qubit can create what number of states. Like here we are seeing 2 qubits, which can represent 4 number of state, right? 3 qubit can represent 8 number of state. And 4 qubit can represent how many state? 16 state. Now, once we are adding qubit, it grows exponentially. Means number of states grows exponentially. So why it is so powerful? Basically, one classical qubit denotes one value. One qubit can denote both 0 and 1 simultaneously. 2 qubit, 4 states at once, and 10 qubit can have 1024 states at once. So 100 qubit becomes more state than atoms in the universe. So now you can understand what is the power of qubits. This exponential growth makes quantum computer extremely powerful for specific tasks. Simple example is a normal computer checking password tries one password at a time, whereas a quantum computer with qubit can check millions at a time, right? Using superposition and interference. For example, 2 raised to power 53 states can be represented by Google chip, quantum chip, which is equal to, you can see the number of zeros in the screen, right? And another example is there is a problem statement, hypothetical problem statement, which a supercomputer can take 10,000 years, whereas a quantum chip or quantum computer can resolve that same problem in 3 minutes 20 seconds. Same way, caffeine molecule can be presented by 200 to 300 qubits, whereas in the classical computer, it can be represented by 10 raised to power 48 bits. Another problem with qubits are they are entangled. Means if we change the state of one qubit, as a result, the linked or entangled qubit, say qubit number 4, 5, 6, or 7, all the states can be changed. Right? For example, imagine you have two magical coins. When you flip them, each coin can land on head, that is 1, or tails, that is 0. But if the coins are entangled, then whatever happens to one instant, it instantly affect the other one. If a coin A land on head, the coin B instantly land on tails. Even if coin B is on the moon, the value means it doesn't matter what will be the position of those two coins. So same principle can be utilized in teleportation also. And why entanglement is important in quantum computing? Like entanglement allows qubit to work together as one powerful system. Computational become exponential faster. Then in quantum communication also, entanglement is very important. Like it helps to create ultra secure communication channel. Any attempt to intercept the quantum link is instantly detected. Means once you try to interrupt or intersect any of the communication, the last qubit or all qubit will be disturbed. It loses its original state. Then in quantum sensing or quantum radar, entangled photon can provide higher sensitivity and better signal to noise ratio. And for the teleportation, quantum teleportation uses entanglement to transfer information instantly. So another phenomena is interference, basically. So here you can see that once signals are in phase, you can have the higher gain. When the signals are out of phase, you will get lower amplitude. So it is very important that we should have same phase if we are getting a meaningful information or where we have to collect the data. Another thing is decoherence. Decoherence occurs when the quantum behavior of qubit decays. The quantum state can be disturbed instantly, but by vibration or temperature changes. So to eliminate this, we are utilizing dilution refrigerator. So this can cause qubit to fall out the superposition and cause error to appear in computer. Right. It is very important that qubit be protected from such interference by, for instance, supercooled refrigerators, insulation and vacuum chamber. So you have noticed in the initial photographs of the quantum computers, all are hanging like chandeliers. Why? Because of the dilution refrigerator. So dilution refrigerator is having that kind of shape. So that is the reason all the quantum computers are like that, except the Chinese one. So as per Google, right now Google is building a quantum computer with 10 raised to power 3 qubit, and they are supposed to come 10 raised to power 6 qubit quantum computer in their M6 state. So right now stage, they are on M3 stage, and they are moving forward to M6 stage. Whereas with the Chinese thing, they are already on M5 stage. So this is the roadmap of IBM. So IBM is right now in between 433 and 1121 qubit. So they are at very initial stage of their Condor chip, which will become a computerless chip. Means to perform the calculation and other thing, they will not require any computer or processing unit along with them. So the chip itself become the computer. So so whatever technologies and other things are there, they are also coming up with great danger. So like adversaries, what they are doing, like China and other countries. So they are just right now infiltrating the data what we are having right now, and they are just harvesting those data. So they are also building the quantum computer. Once they are ready with the quantum computer, they will be decrypting all the national secrets and other whatever they have taken from our country. So what they are doing, they are just harvesting data. That is adversaries collecting encrypted data. Right now, they don't have decryption technology. So they are storing. Data remains encrypted with the current standards. They are waiting for technology's advancement. So once they are ready with the quantum computer, they will be breaking all the encryption, and then the secret will be theirs. Now, what another danger coming along with the quantum computer, like making asymmetric cryptographic obsolete. Like asymmetric cryptographic basics, it involves two keys, a public key, which can be shared openly, and a private key, which is kept secret. The public key encrypts data, and the corresponding private key decrypts it. Then second, this method underpins many security protocol on the internet, including SSL, TSL for secure web browsing, and RSA for secure email communication. Now the vulnerabilities of the blockchain also will be exploited with the quantum computer, like digital signature. Blockchain often use digital signature for transactions verification. For example, Bitcoin uses the elliptical curve digital signature algorithm to ensure that only the owner of the Bitcoin can spend them. These signatures are secure against classical computing attack, but not against the quantum attack. Second is hash function. Blockchain uses cryptographic hash function to maintain the integrity of the blockchain and the chain, while hash functions are somewhat resistant to quantum attack. They are not entirely immune. So those vulnerability can be exploited by the quantum computer. Right? So actually, quantum computer poses a significant threat on the blockchain technology, primarily because it can potentially break the cryptographic algorithm. Right now, it is predicted that near about 4,000 qubits are required to break the RSA algorithm. And very soon, various countries are going to achieve, because country is funding quantum computers, means whosoever is making quantum computers, state is funding them. Now, what will be the impact on national security? That is, we are well aware that right now, means with the help of Shor's algorithm, when run on a sufficient powerful quantum computer, can efficiently solve the integer factorization and discrete algorithm problems. This means it can break the cryptographic security that protects private key in blockchain or any other system. Right? In this context, the blockchain, this means the quantum computer could derive a user's private key from their public key, undermining the security of digital signature. Now, another algorithm is Grover's algorithm basically. Grover algorithm provides a quadratic speedup for finding the pre-image of a hash function. So as a result, what will happen? So they are going to break both the algorithms. With the help of both the algorithm, it is going to break the blockchain and other current security systems. So as a result, what will happen? Whatever data has been stolen and whatever encryption technology we are utilizing, those technology can be breaked. Now, it is also going to impact on the digital infrastructure like financial systems, online identity verification system. In the financial system, secure financial transaction rely heavily on the cryptography. What cryptography? RSA. Basically, they are utilizing RSA cryptography, which could compromise by the quantum computing. Another thing is the online identity verification. Systems like SSL, TLS for secure web browsing could be rendered ineffective, impacting e-commerce and online communication. Now, what will be the computational implication? Like there will be challenge of algorithm supremacy. Quantum computers could solve certain types of problems much faster than classical computer, potentially distributing computational paradigms in the field like optimization, simulation, and material sciences. Means they are going to shift entirely, means whosoever is having the quantum computer, they will be more powerful as compared to other systems. And then there will be a challenge with the ethical and private, means there will be challenge in ethical and privacy concerns basically. So, and healthcare and research system also means there will be records of the sensitive records of the patients, and biotechnology and pharmaceutical research, they are also right now encrypted with RSA. With the help of the quantum computer and other technology, these can be breaked. So here in technology sector, like obsolescence of current hardware, the rise of quantum computing might render some current computing technologies and infrastructure obsolete. New software needed means extincting software and platforms might need significant re-engineering to operate on alongside quantum computers. So there will be complete shift of technology, and to achieve those things, we need to invest heavily on that. And there will be a clear digital divide, which can grow, which will be growing exponentially. Like I told you earlier, that a huge social risk of quantum computing is the exponential growth of the digital divide. The high cost of quantum computing will mean only the wealthiest will have the access to its immense power, which could be used to exploit and accelerate the difference between the halves and the half not. People, companies, or government unable to afford quantum computing services may be left behind. So business need to invest heavily if they have to be in this particular race, and as a result, what will be there, that a complete technology shift we can expect in coming years. So in short, if we summarize, what will be the computing threat, like in cryptographic system, the breaking current encryption, compromising data security, threat to blockchain technology. In cyber security, increased hacking capabilities, vulnerabilities of the sensitive data, new forms of cyber attack. In privacy concern, decryption of the historical data, eavesdropping on encrypted communication, exposure of personal and financial information. Last one is global security, where the impact on the national security, threat to critical infrastructure, and uh, disruption of the military communication. So these are the challenges. Now, why PQC matter on the drone security? PQC is post-quantum cryptography. So now I have seen your agenda full day. So you are right now learning on drones and drone technology. Can someone tell that how it is going to impact drone security? Anyone? People are there? Can someone tell how quantum computer is going to disrupt the PQC? Means right now algorithms, whatever algorithms are there, and how drones can be endangered in, or drone communication can be uh, broken. Okay, nobody.
Actually, sir, according to me, the in quantum computing as compared to the conventional computing, it is more error prone. So I think in the field of communication, the chances of getting that error is more in terms of drone communication if we use the quantum computing, as per as my knowledge that I can tell.
So right now, as you rightly said, the quantum computing, it is more on errors. Means right now, all the engineering is, or the countries are investing on getting the error-free results. So Google have already achieved 100 qubit, which are error-free. 422 qubit is already achieved by IBM, and 1000 plus qubit is already achieved by China. So means people are working and investing heavily on the getting the error-free results. But now my question is, how quantum computer or post-quantum cryptography is going to affect drone communication or drone security? Like in this presentation, it is written that drone rely on encryption to protect telemetry link, command and control link, video streaming, firmware and OTA updates, drone-to-drone SWAM communication, GNSS-based navigational integrity, remote ID and UTM communication. So all these links are having some type of encryptions, right? Like we are utilizing RSA, ECC, Diffie-Hellman, AES. So 99.99% people are aware about the AES 256 and AES lesser bit encryptions. So right now we are utilizing AES encryption and other thing. In banking system, RSA encryptions are utilized. So with a quantum computer, all these encryption will be in danger. Means they can be decrypted very easily. Like quantum computer can break RSA ECC within minutes or hours. Like drone command and control link can be hijacked. Drone telemetry can be decrypted. Firmware can be spoofed. Swarm drone can be redirected or made to collide. GNSS anti-spoofing signature can be forged. Remote ID signals can be faked. This makes drone highly vulnerable in post-quantum world. Now, what are the major drone security threat in post-quantum era? So, quantum computer poses a severe threat to the command and control link of drones. Currently, many drone systems rely on elliptical curve cryptographic, which is known as ECC or RSA-based key exchange protocol to secure the communication channel between the means ground-based station or remote control. Quantum computers leverage the algorithm like Shor's algorithm, can efficiently break these cryptographic algorithms. If successfully, an attacker could inject commands, gain unauthorized control over the drone by injecting malicious commands into the C2 system, command the drone to land prematurely or in an unintended location. It can also change the GPS waypoints. After the drone's flight path by modifying its GPS waypoints, potentially lead to a astray or into the dangerous area. Then it can also kill the motor, shutdowning the drone's motor mid-flight causing to it crash. Send the drone to hostile territories read by GNSS spoofing. Right? It can also manipulate the firmware, drone to drone, swarms attack. It can do anything. Now, what is the solution? The solution is that we should develop encryption system in such a way that it should be quantum attack proof, right? Like post-quantum cryptographic offers a solution by replacing the vulnerable ECC or RSA algorithm with quantum safe alternatives. By implementing PQC protocols for key exchange, the C2 link can be protected against the quantum attack, ensuring the integrity and confidentiality of the commands. And telemetry data transmitted by the drones contain the sensitive information about the drone status and mission. This data is often encrypted using the classical cryptographic algorithm. A quantum adversary capable of decrypting these telemetry could gain the access. So that's why we need to replace these algorithms with the post-quantum or quantum safe algorithms. So in global navigation satellite system, that is GNSS system, such as GPS or Baidu or GLONASS, are crucial for drone navigation. However, GPS signals are vulnerable to spoofing attack, where an attacker transmits false signal to deceive the drone about its location. Most GPS anti-spoofing signatures rely on the classical cryptographic algorithms. Quantum computer can forge these signatures, making spoofing attacks extremely precise and difficult to detect. This could lead to navigational error, causing the drone to deviate from its intent course, losses control. And what will be the solution? Solution is that PQC can secure GNS authentication protocol by replacing vulnerable classical cryptographic algorithm with quantum resistance alternatives. This makes the significantly more difficult for attacker to forge GPS signal and spoof the drone's location, enhancing the reliability and security of drone navigation. Now, fourth threat is firmware manipulation. Firmware upgrade files are typically signed using RSA or ECC. So everywhere we can see that RSA and ECC are common. So we need to basically keep in mind that moving forward, we need to have some alternatives or hybrid post-quantum cryptography, where it supports the classical cryptographic technologies as well as advanced quantum resistance cryptographic technology. So in drone swarms consisting of multiple drone communication and coordinating with each other are being increased common. These drones typically communicate using peer-to-peer encryption link. Quantum attacks can compromise these links and split the swarms. Basically, it disrupts the communication and coordination between the drones, causing the swarms to break apart. And it can also introduce a rogue drone into the swarm by spoofing its identity, potentially disturbing the swarm's operation or carrying out the malicious action. It can also disable the synchronization between the drones. And it can feed incorrect sequences or consequences information and manipulate the algorithm using by the swarm to make decision, causing the drone to make incorrect harmful choices. So what is the solution of that? That is developing post-quantum cryptographic and encryption solutions. For organization, it is important to build awareness of the threat quantum computers can poses beyond the cybersecurity expert to the senior leaders and executive decision makers. This will help organization to develop a more cohesive response across different level and stakeholders. Right? Government and business have already begun preparing the post-quantum world. For example, CISA and NSA recently released quantum resistance algorithm recommendation and requirement for the critical infrastructure and national security system based on post-quantum cryptographic selection from NIST. Then organizations can focus their strategy on crypto agility, by which they will be able to switch between crypto algorithms seamlessly in case one or more become vulnerable to the attacker. For enterprises hesitant to adopt new and untested algorithm, there is an option of integrating classical quantum-based solution for a hybrid approach. Other technologies like post-quantum cryptography or technology based on the characteristic of the quantum mechanics, think quantum key distribution and quantum random number generator, is also a way of strengthening quantum cryptography. Now, how we have already discussed that how PQC strengthen the drone security. Like PQC, key exchange crystal kyber, replaces ECC RSA, protects live command and control links. And what are the benefits if we replace ECC RSA with the crystal kyber? which is one of the PQC algorithm that it is resistance to quantum attack, low computational cost, suitable for microcontroller like in electronic means people from electronic background can have pink board, which is Python based board, or Raspberry Pi, or there are similar type of boards where you can utilize Zinc 7020 processors to implement these algorithms, and works on existing RF, LTE, and SATCOM links. So whatever communication channel you are utilizing, you can decrypt those channels with the PQC algorithms. Now, another thing is PQC digital signature, dilithium or Falcon. You can utilize these algorithm, dilithium and Falcon. Basically, these are lattice-based algorithm. It can used for firmware integrity, over-the-air updates, drone identity verification, or remote ID authentication. Then PQC secures GNS authentication, means quantum safe signature ensures anti-spoofing, navigational integrity, mission reliability. And PQC for drone swarms can be utilized for mutual authentication, secure peer-to-peer messaging, consensus integrity, formation control. And PQC in anti-drone or counter unmanned aerial system ecosystem, that adversary drone may soon be use PQC to secure their communication link. Means uh, everything is that they need to secure themselves. And in this direction, we have made Bhumi has made post-quantum cryptographic HSM module, where we are utilizing all the algorithms, like whether it is McLeese or lattice-based, code-based, hash-based, or any kind of algorithm. We are generating the public and private key, which is distributed, and DRDO right now utilizing this HSM module, which we built for them. So, any question? Actually, I have completed my session, so there was no question. I was expecting some. Anyone? Actually, I have completed my session. Okay. There are few more information which I want to give. So there are detailed, I'm going to share this presentation with you. So there is a detailed description about the symmetric, asymmetric, and other type of cryptographic method, and the mechanism and drawbacks, what they are having, and how it can be replaced with the PQC algorithms. Like RSA was more suitable for number theory, and key size basically typically it varies from 10242 to 4096 bits, and application was digital signature, security, key exchange, and all. And ECC's application is secure communication and digital signature, right? So these are the mechanism how this key system works. Now there is a comparison between RSA and ECC. So these are the classical uh, encryption algorithms. So I will be sharing this slide with you. So this is one simulation done by IBM. So they are predicting that by when this classical cryptography will be baked. So it is going to extend near about 2035 as per IBM. But China is working very hard to break this by 2029 or 2030. So as per this simulation, IBM is going to break RSA by 2035. So NIST, basically they are organizing multiple challenges, and right now they have organized 3 challenges where they have selected this 5 category of post-quantum cryptographic codes algorithms. Basically, these are lattice-based cryptography, code-based cryptography, multivariate polynomial cryptography, hash-based cryptography, and isogeny-based cryptography. So these are the basically various steps how this cryptography works. Now, I was talking about the National Quantum Mission. So you can see in orange color India. India has allocated 60 billion rupees, which is equivalent to $735 million. And 60 billion means 6,000 crores. Whereas USA, they have allocated $3.75 billion. Germany, $3.3 billion. Canada, 1.1. Australia, 155 million. Then Israel, 390 million. And if you sum total many of the countries, then China alone is spending $15 billion. And you can guess why they are spending heavily on quantum computing. So as per Indian quantum mission, the National Quantum Mission was announced in 19 April by Union Information Broadcasting Minister Anurag Singh Thakur and Minister of State of Science Jitendra Singh, with a budget of 6,003 crores over 8 years. It is aimed to develop 50 to 100 qubit of quantum computing hardware. Right now, we are on 7 qubit, which is developed by New Scientist Lab by DRDO with the association of Tata, TCS, and Tata Research Foundation. And we have also tested, and second mission is 2000 kilometer of quantum communication network and foster a domestic ecosystem of quantum research. China has already done over the air quantum key distribution thing, means from ground to satellite. And we have successfully conducted 350 kilometer of quantum key distribution from Prayagraj to Vindhyachal, where DRDO, IIT Delhi, and two more private organization was involved. And this is global market size of quantum computing, means it is not related with the quantum computing itself. There are many other technologies or fields inside it. After quantum computing, there is a random number generator or quantum post-quantum cryptographic or quantum key distribution, quantum radar, quantum sensing, quantum memory. There are a lot of research area where the product with the quantum preface, they are having market of near about 125 billion USD by 2030. But I am assuming it by 2029 it will be more than $200 billion. So these are the few companies in America, EMEA, and APAC region. EMEA stands for European and Middle East America. APAC is Asia Pacific. So these are the few companies which are into quantum domain. And as I told you earlier, I have shown you 2 quantum computers. Left was IBM, right was Google. So here you can see that both the CEOs are Indian, right? So we are having Mr. Arvind Krishna on the left hand side and Sundar Pichai on right hand side, right? So with this, I'm going to end this session. Do you have any doubt or query?
Sir, I'm Professor Raghavendran. I have one query.
Right.
Will AI co-work with quantum computing, or will quantum computing take over AI, or is there a comparison or communication between these two, or how is it?
Yeah, it is going to basically quantum computing is also, it means algorithm will be same.
Okay.
So whatever AI algorithm you are utilizing, so quantum computer, with the help of quantum computer, it will be more faster, but algorithm will be same.
Okay, because nowadays we are seeing other than GPUs, we are seeing something called as NPUs, neural processing units, and with quantum computing we see even QPU, that is quantum processing
Yeah, right.
units.
Right.
And we would like to know more about the hardware part and how it functions, as how best we can actually work on this part if you have to work on.
Basically, it is too early to say regarding the quantum infrastructure. Right now, people are still struggling to harness or to have the stable qubits. So that is one thing. But yes, very soon with the help of quantum memory and other thing, when the infrastructure will be developed, many of people are working together in this ecosystem. Like in this particular slide, you can see that superconducting, trapped ion, photonics, neural and silicon and other. So there are so many companies who are working on quantum memory and other things. So once everything will be ready, means whatever algorithm you are developing, whatever processing you are doing, number of qubits you are developing, but they have to be stored somewhere. So we don't have right now the power to harness the results of the quantum computer. So once the quantum memory will be ready, at that time we'll be utilizing the results, whatever quantum computer are generating. But that is for sure that the algorithm what we are having right now is not going to replace by quantum computer.
Thank you very much, sir. Thank you for so much of insight, sir. So it's very much beneficial.
Right. And it is basically what I'm trying to say, that we have already built this post-quantum cryptographic HSM module. We are working on quantum dots and quantum radars. And why we have developed this post-quantum cryptographic, if you are interested, I can show you something. So here you can see this. It is we are going to make this open source. Basically, everybody can utilize this. So we are generating PN20 pseudo random number 20 sequence with the help of pseudo number 20 sequence. We can double encrypt whatever encryption is there. For example, Kyber, if we are utilizing Kyber to generate the key, here we have generated the key. Once I download this key, I can open this one. My screen is visible with the keys.
Yes, it's visible, sir. Yes, sir.
Yeah, here you can see that with the help of Kyber, we are having this much public key, and this is the private key, what we are achieving. It is double encrypted right now. So it is also encrypted by AES, means it is we are utilizing Kyber algorithm to generate these keys, and we are also encrypting this Kyber algorithm with AES, where the seed of AES encryption is pseudo noise 20 sequence, and pseudo number 20 sequence is generated with the help of true random number generator, which can be replaced by quantum random number generator. So we can utilize any of the sequence. Once we download it, it is already deleted. You can see the logs and other things. Here we are giving the API interface also. So this very soon we are going to make available for everyone free of cost. It will be open source thing and you can download and practice and you can modify these things. All the documentation is here. So it is pqc.ncubit.com and the ID and password is yes. ID is admin and password is password. All are in small letters. So you can utilize and you can generate the keys, you can check and you can play with this. So with this, I'm going to end this session. If you are having any doubt, please text me or you can send email to me. Shall I log out? If you are not having any question?
Meda, please ask if there is any question. Otherwise, we can close the session today's.
Right. I guess there are no questions. So thank you, everyone. Thank you, sir, for having me here. So
Thank you, Vikasji.
I will be sharing this PPT. You can distribute among the participants if required.
Okay, thank you.
Right, right. Good night. Bye-bye.
Good night. Good night.
Good night, sir. Thank you.
Thank you.
Please keep active for 5 minutes so that once again I can share the link. Stop the recording. No problem.
Recording stopped.
Now we can close the session. Also, thanks to all my team members.
Thank you, sir.